Okay, change of plans. So please take note. It's updated on Moodle and should be on Renwell, but I wanted to go over it with you here in class. We're having a test next Friday. That's 1 week from today. Okay? Now, we're about to go over the last part of what's going to be on that test. We're not going to get to the you-do substitution before the test. We're just going to make this test a little bit shorter so we can get it in faster. But what I need you to understand is there's only 4 days next week. Okay? Monday is a work day for you. Excuse me, Tuesday is a work day for you. Wednesday, you will not be here. Thursday, it will be the only time, will be review and work, and Friday will be the test, okay? So plan your week, plan your time accordingly so you can get ready. I will have something in the form of review material for you when we come to class on Tuesday posted. I don't know what that is yet, but I'll have something for you, getting you ready as best for the test. But notice what you've got the web assigned tonight. There's another video problem due next Wednesday. There are 4 FRQs due next Friday. Those are things that you can go ahead and begin working on. Should you choose to wait to the 11th hour, that's your problem on that. So please don't wait until the 11th hour on that, okay? All right. Now we're still in 30. We're going to finish 30 up before the test. 31 will be... 31 will only be after the test, the you-do substitution. Okay? I want you to think about, this problem was giving you difficulty a while ago, so I want you to think about something. Suppose I gave you a function, and this is what the function looks like, okay? And let's say that function is f of x equals I don't know, the square root of x plus 2. The square root of x plus 2. And I said find the, and what if I said integrate from 0 to 2? Could you do that?
Yes.
Yes. What would you do?
Integrate.
Find the antiderivative and evaluate. Okay? Well, I also want you to integrate from 0 to 3. Can you do that? If I said 0 to 4, could you do that? 0 to 10? Anything I said. But each one of these is a separate problem to have to deal with. All right? Now, I'm lazy. How can I write that so that it's easier, so that the same information gets across to you, but there's not as much to write down from a teacher's perspective, but also from a student's perspective, so that it's written so that, wait a minute, I don't have to do all of this work really. I don't have to integrate 7 times if there's 7 problems. I've got to integrate 1 time and then just plug numbers in. We can do that by looking at something like this. That's all this terminology means. Now, my typo had x's in all the places. So the way it should really look is f of, and I'll use t, is the integral from 0 to t of some function x dx. Now, don't get hung up on the letters. As long as there are 2 different letters, we're okay. All right? As long as you've got a set of letters here within the integration and a different letter out here, it's okay. Can anybody tell me what would be the problem if all of these letters were the same? What if this were x's? What if I said this is what I want you to work right here and left all those as x's? That's right. What's the first thing you learned when evaluating functions? To evaluate a function, you plug in the value, right? Well, what happens if I plug in 0 for x? That means plug in 0 everywhere, right? So that would mean a 0 right there. We'd say f of 0, f of 0 equals the integral from 0 to 0 of the tangent of 0. What's the problem with integrating tangent of 0? What's the tangent of 0? Yeah, but it's a constant number. In most cases, well, it's a constant number. In most cases, that's a constant number, right? Once we plug that in, so if it were something that if it were 5, then how would you integrate 5? It'd be 5x, wouldn't it? Totally different. Do you see? If we have all the same letters here, this is a totally different problem, and suddenly it's not something that we can do very easily. Okay? So now, think of this as just a different way of writing multiple problems here. Well now, how does that helps me as a teacher. How does that help you as a student? If this is our problem here, and I asked you to evaluate it at 1, 2, 3, 4, 5 different variables. In fact, let's change it to something we can do. Instead of tan here, let's look at it as sine of x dx. What can you do with this part right here now? What? Negative cosine. So this means that f of t is really just minus cosine of x, minus cosine of x, evaluated at 0 and t, isn't it? Agreed? Well, can we evaluate it at 0 and t? What happens when we put t in there? Well, but we can just put the letter t in there to begin with, can't we? We put in the top minus negative cosine of 0. Can anybody tell me what the cosine of 0 is? 1. So this becomes minus cosine of t plus 1. So look at what our function is. We've taken our integration function and changed it into something that doesn't have integration in it any longer. Can you evaluate this function at 0, at pi over 3, at pi over 2? See, so suddenly now, when you first looked at it, looked like I've got to integrate something 1, 2, 3, 4, 5 times. Now you only had to integrate it one time and plug in 5 different numbers. So doesn't that make things a little bit easier for us? Okay? When you see this written, or now let's start a new page. Now I want to take this, keep going along this same lines here. We're going to stick with the same function. F of t is the integral from 0 to t of the sine of x dx. And we've worked that out, and we found out that that's minus cosine of t plus 1. Right? Okay. What does the sine of x look like graphically? Yeah, it's something like this, right? All right, so if we were going to integrate this from 0 to pi over, well, all right, let's go to our next question here. What is f of 0? To evaluate f of 0, we're just going to plug 0 in here, right? What are we going to get? 1, negative 1, plus 1, we get 0. Now, we're going to tie this to the graph. We got this function by integrating, right? What does integrating mean graphically? The what? Area. So that's saying that the area from 0 to 0 is 0. Does that make sense? If I start at 0 and don't move, how much area did I cover? Absolutely none. Well, what about pi over 6? Pi over 6. What's the cosine of pi over 6? Can anybody tell me? Root 3. Pi over 6 is right here. It's root 3 over 2. Root 3 over 2. So we'll put root 3 over 2 here, a negative sign in front of it. 1 minus root 3 over 2. What does that mean graphically now? Well, pi over 6, let's say, is right there. That's probably too far. Pi over 6 is right there. So suddenly the area right there has become that amount. And if we do pi over 4, What happens when you put pi over 4 in this function? What do you get? Root 2 over 2, so it becomes 1 minus root 2 over 2. So let's say it's here at that line. Now, does this function value here include this one up here? Because it's area, okay? So do you see, and if I go to pi over 2, pi over 3, it's going to keep growing, right? This is sometimes called an accumulation function. Accumulation function, okay? Why do you think we call it an accumulation function? We're accumulating stuff, aren't we? We're adding area each time we go up. All right? So that's all I want you to understand from this, okay? Now, I'm going to ask you a totally non-math related, easy question that everyone's going to hesitate to answer. Okay? You ready? What color is the White House?
White. Brown.
What color is the White House? White. Okay. That's very obvious, right? Everybody's wondering what's the catch, right? There is no catch. That is the correct answer. It's white, okay? Now, I'm going to ask you a very similar math question. If I integrate f, this function, and then take the derivative of it, what do I get? What I started with. That's obvious, right? Exactly. That seems kind of counterproductive, doesn't it? But that's the second fundamental theorem of calculus. That's the important part. And for us right now, that seems very unnatural to say. Who can't figure that out? Okay? But I want you to understand it is important for us because I'm fixing to give you two examples and you're going to miss one of them. Okay? Guarantee you're going to miss one of them. You're going to get one right. I guarantee you're going to get the other one wrong. And then we're going to show you why. Okay? All right? So, what's the answer?
That.
What is that?
Square root of 3 squared minus 5.
That's the answer y'all want to go. Now, I changed it to x's because we're integrating from 0 to x and we want to know the derivative with respect to x. Okay? So, is everybody agreeing with that answer? Okay? Okay, yes, find the derivative of f. So what's the answer?
Not that, because you said we're going to get wrong.
I didn't say the other one was right yet.
Well, then that.
When you integrate that, you get
Negative cosine.
Yes, it's going to be a positive. It's going to be a negative sign. Negative
Those are positive.
There it is. Negative.
That'd be negative.
Whatever you
Okay.
do, it's not that.
All right.
No, look, the derivative of cosine is negative sign. So it's negative cosine positive.
Okay.
Which one was the one where the picture is wrong?
One of them. I'm not going to tell you, okay?
And you already told us other one.
I did not say the other one was right. Y'all implied that it was right. Y'all inferred that it was right. Okay. All right, so now, Brandon said, tell us what you said over here, Brandon.
We have to integrate it.
All right, let's integrate it and see what we would get. This one here we are not smart enough to integrate this, okay? We can't integrate this thing here. So, that is the correct answer there. That is the correct answer. Now, over here, had y'all come up with an answer, it would have been wrong. All right? So now, let's integrate this and see what part we're missing here, all right? So if we integrate sine, what do we get? Negative cosine. So we've got negative cosine of t, and we've got to evaluate it at pi over 2 and x cubed, right? So that means we're going to put x cubed in there, and we get minus cosine of x cubed. I'm putting it in parentheses, so we'll remember the x is being cubed, minus negative cosine at pi over 2. Agreed? All right, can I simplify that any?
Yes. Cosine of, negative cosine x minus 3 minus plus.
Minus cosine of x cubed, minus negative, make that plus. Cosine of pi over 0 is 0. So we could really simplify this all to say that our function is equal to minus cosine, oh that looks terrible, minus cosine of x cubed. So by integrating, we've simplified that our function is minus cosine x cubed.
Oh, I see it. It's 3. Right. We didn't do the x cubed.
Okay? Well, how does that change things?
Because now we put it together. I don't think we will have to.
So now, what is f prime? Be careful, you haven't taken derivatives in a few days. Y'all are going to miss this, I'm afraid. Have to do the chain rule. Well, you're so smart. Talk us through it, Connor.
Put 3 down in mind. And it's a 3 cosine x cubed. 3 cosine x cubed. But it's negative.
I hear that.
Plus.
I hear that.
Where the negative go?
Oh,
Negative.
It's to the second, but it's negative.
Yeah.
Then
It's the first one plus
What's the derivative
x
of negative cosine?
cubed sine.
All right?
But there's a negative out for that.
Anybody else?
You can just write it. The answer is potato.
Y'all really know how to make somebody feel good here today, okay? All right. Now, how do we take a derivative? You said chain rule. That chain rule is correct. Okay? So, remember, chain rule, we have an outside function and an inside function. Right, so first of all, what's the derivative of the outside function? Sine of the same thing times the derivative of that, 3x squared. Okay? Yep, you were thinking product root. So now that is the derivative. Come on, y'all got to focus here, okay? You got to focus. That's the derivative. According to what we just talked about, was obvious that the derivative of the antiderivative is back to the same thing. No.
When there's a variable in there, does it change? When there's a variable.
When there's a
I know there was a variable in there.
All right, okay, I'm hearing a lot of things, so let's try to take them one at a time here. So hold on. I heard somebody say, is it because it wasn't 0 on the bottom? Okay, let's think about that. If it's 0 here, we would have plugged 0 in here and got the cosine of a 0, which is still a number, right? And the derivative of a number is always 0. So this part's going to disappear. As long as this is a number down here, that part's going to disappear anyway. So the fact that this is pi over 2 and the other one's a 0 doesn't make a difference there. Okay?
Negative trig function is what derives
Is it because it's a negative trig function? It's not because of that, because I could give you that same integration and put x squared there, and the answer would be totally different again. The answer would be 3x to the 5th.
This is just a fraction. I'm going to divide by
Okay? So neither of those. What is it? So be careful.
What you're going to.
Yes. This is the huge part up here, okay? Yeah, but Thingy just wasn't getting to me there. Her little thing, all of them together, y'all had to put them, once we got there, we're okay. But the fact that the upper limit of integration was something other than x. Okay? So, if we're talking about this here, I'm going to go back here and put a big star here. Okay? 3 stars, maybe 4 stars. Right here. If the upper limit of integration is something other than x, comma.
So it'd be different even with x squared.
That's right, it'd be different even with x squared. Now, I still want to use this thing and not have to integrate and then antiderive it. I don't want to have to integrate it and derive it. I mean, that seems like a waste of time. So how could I look at this? Let me find it. Tell me, how could I look at this thing here and just know that f prime then is okay? Does everybody hear what she said? She said derive the top, derive the x cubed, 3x squared,
And then plug it in for the
and plug it in for the argument over here. Does that make sense? Okay. She said take the derivative of the upper limit of integration, 3x squared, and then plug the upper limit of integration into the function. All right? Does that make sense? Okay, yes. Other than x, then you are doing chain rule. Yes, we're just doing it instead. Derive the upper limit of integration. ULI, okay? I'm going to write it up here so you'll know, because I'm too lazy to write out those 3 words. They're too long. Derive the upper limit of integration and multiply it by the function evaluated at the upper limit of integration. Do you understand what I mean by evaluated at the upper limit of integration? What does that mean? Plug it into the function. Okay? No, it's not complicated. You're going to forget it and you're going to miss it, but it's not that complicated. Yes. Yeah. The answer was the function sine evaluated at x cubed times the derivative of x cubed, 3x squared. So you've just got to be careful with that. Now there's going to be a problem on this next test like that. There's going to be a problem on the exam in May that needs that. So just be careful with them, okay? They're very important that you understand that difference there, okay? That's the only hard part about the second fundamental theorem of calculus. That's right. It's easy as long as you remember it. Now, listen carefully. There are, after your turn, there are 11 problems. I want you to work those 11 problems to be turned in when we come back on Tuesday. Okay? I'm changing things up because it's not listed anywhere on Moodle or RenWeb anywhere, but they need to be turned in, prepared to be turned in on Tuesday when we come back. So I can look at those and get a better evaluation of where you are moving forward. I'll have review problems for you to do when we come in on Tuesday. You've got FRQs you can work on. You've got your video problem to work on. So you've got plenty to do. I'm not doing this just to give you extra work. I'm very concerned how much y'all are going to blow this first test if we're not careful. And this first test is the easiest one we'll have all year. So just please, we need to be careful with that. I want you as prepared as we possibly can get you, okay? Any questions?
And this is just the stuff we just did.
And this is, What do you mean? Yes, all of this stuff is just over, no, all of the stuff here is over integration in general. Some of it is what we just did in the last 15 minutes. Some of it is directly off of the WebAssign. Some of it is integration. It's a decent review in and of itself of what you need to be able to do going into the test.